Good. Okay. So of course you only need to write down the information you need, not everything I say. So here's the question. A physics teacher is making an Irish coffee. He has 50 grams of whiskey, 100 grams of espresso, and 300 grams of water. Got that? 50 grams whiskey, 100 grams espresso.
That's an Irish coffee?
Yeah. It has cream and other stuff too. 100 grams of espresso and 300 grams of water. You got that? Okay, so part A. How long would it take to heat the water from 10 Celsius to 100 Celsius by using a 2 kilowatt kettle? So I'll say it again. How long would it take to heat the water from 10 to 100 Celsius by using a 2 kilowatt kettle? Okay, try part A.
Heat the water.
Yes.
How many minutes?
You can give me the answer in minutes or seconds.
Kilo? 128. No, let's see. Thank you for Thank you. We got a cute little projector. Be strong. Hi, so are you finished? Good. Yeah. Good. They're doing the first question in the homework.
What about the
Here,
question?
you can take a picture on your phone. Yeah, I'll do that in a minute once I have the projector on. Whoops.
Oh.
Huh? Oh yeah, it's okay. Don't panic. Stay calm. Right, so let's try out the cube projector. Look, you can get a little stand and everything.
Who's the person?
Isabel usually uses this one.
But it's not Isabel.
We probably use it
Yeah,
for presentation.
Look at that. That's great.
Bluetooth?
Maybe. How do you lock this or something? Ah, I see.
Are we gonna do the question from?
Yes, that's fine. Just ask me. Maybe I need to plug it in.
Second? Second.
Now, can I give you the part B? Yeah. Okay, part B. How long would it take to heat the espresso from 10 to 80 Celsius by using a 3 kilowatt coffee maker? Oh, I use those too.
This?
They're my favourites.
For what?
Yeah, freshen up.
What's the power?
3 kilowatts. Just like how she's doing. We're so similar. So similar.
So it was a different question.
No.
There is capacity for espresso.
Oh yeah, and
Water.
I want you to assume the espresso is like water, although it's not. I couldn't actually, believe it or not, I couldn't find the heat capacity of espresso online.
Wow.
Hold on. Steady.
You're doing the wrong thing.
Here, teach me. And then here's the cable for it. We'll definitely need the lights off, Andrew, if you don't mind, please. Okay, do you have part B done?
No.
Is it connected to your laptop?
I'll do that. VGA, please.
It's not big fan job.
Hold on. 1 second, let me resend the signal.
Oh, it's farting. It's like a drrrr. It's working now.
Maybe we can adjust the lens for maximum magnification.
There is no magnification. There is only focus.
Oh, it doesn't matter, I'll have to do.
Nice.
Here,
Go ahead.
it needs the power cable, huh? No, you know what? Leave it plugged in. I know. Don't worry. Don't worry. The explosion will be quite small. It most likely won't be fatal.
To be fatal.
No. That's so bad.
This is has a battery in it, so once it charges up a little bit, we can move it back more then.
Oh.
Mm.
How do you see the charge?
Mm. We'll leave it on for the first lesson. Okay. Do you have the second one done?
Yes.
Alright. Let's just put the answers down. So for the first one, we wanted the time. So what formula did you use for that?
Yeah.
Q equals MC delta, and then we use Q equals P over T.
Yeah, you need to use
The power formula.
Power is work over time, and the work here is the Q. Okay, so let's write that down.
So not 66.
Power over time.
Yeah, part A.
No, it is.
Power is work over time. Time is work over power. The work here is MC delta theta. So, what's the M?
0.3.
The C? 4181. Delta theta is 90.
Yeah.
And the power is 2000. And the answer is? Great. Seconds. Okay, and B is basically the same, isn't it? Except different, yeah. So, it's the same idea, and the answer for the time is?
8.4.
9.8.
Ah, dude, come on. 8.36.
Oh,
9.8.
Yeah, what is
9.8.
9.8.
Quiet, children. All right. What is the power here?
3,000.
3000. The M?
0.1.
0.1. Yeah? C?
4.
4181. And delta T?
70.
70. We'll see then.
How's it 70?
Yeah, right there.
Ooh, awkward for you, Yusuf. Awkward. 9.8.
How is it 70?
Read the question.
From 10 to 18. Or 80.
9.76 seconds. Okay. C, which we haven't done, but I'll do it now. The cold whiskey is at temperature 20 and is added to the hot espresso. What's the final temperature? So you have the cold whiskey added to the hot espresso. What temperature is the espresso at now? No, the espresso I think is at 80, isn't it?
80.
And how much espresso?
I don't like this. We can't see the small squares.
Are you gonna draw small squares?
No, I just got to fix something. Just a second. Here we go. Now, unplug it. I might have enough battery power for a couple of minutes. What the heck?
I will electrify you.
Don't!
But that means I have to move the table, which I will do in a second.
You can move forward.
Just a sec. Just a sec. Actually, much better.
Yeah. Adjust the focus.
Fun!
Phone didn't have to move.
No.
Or it has to be
Wait.
like this. Or that.
Wait. What happened? It's here. Yeah.
But we don't
Faisal,
want
can
Faisal
you
to
fix
move.
the stand? You seem to know how to do it. Fong, I have to move because my cable won't reach from here.
So you move it.
And you will need to move too.
Sit next to Lee.
Yeah, sit next to me. I'm leaving you now. Goodbye. Don't fall asleep, please. I don't want to get drool on me or anything. Maybe I can do it better when I'm behind it here.
So one, your hair is nice. Please stop and move.
Fine. Move.
Okay, Fawn, you have to move. Touch up. Oh, it's when you connect the,
I think it's that, yeah, that's what I was meant about. There's no square.
Still no squares. Good enough. Right. Continuing.
Yes.
Hi, so please. Do you need to move? Yes, you do. Go sit beside Wong. I know, but be strong.
I'm not going to.
Okay, then you can stay if you're good.
No, I was happy that Swan is not next to me anymore.
Right. C. What did we say the temperature of the water is?
Then
No.
take it to
100.
Wait, is it on the water with the espresso?
No,
I've
it's
forgotten
whiskey.
now. On the whiskey, sorry.
Yeah.
So I shouldn't use W for water and whiskey. What temperature is that at? No, 20. And it's 50 grams.
But if you scroll back,
The espresso is different.
yeah, 0.1 for the espresso.
Okay, thank you. 0.1. And then the alcohol is 0.05. And the temperature is 20. Let's just change the name of this to alcohol. Okay, so the question is, when you mix them together, what's the temperature you get at the end? You understand?
Yeah.
Okay, I'll give you a minute to try this one now. Look, Faisal,
yeah.
here are your squares.
Yay!
Feel better? There we go. Oh, I
What
can't
do we
believe
want?
we have 3 hours. What?
What we want?
I want to know the temperature of the mixture at the end.
Of this one. This thing.
Move, move, move.
What is the E?
Espresso.
What's that?
Coffee. You never had espresso? Coffee.
It's not a nice color.
Wong, could you pull the other blind down more? The one on the right. Yeah.
This?
More. Ah, that's better.
It's x minus 20, x minus 80, right?
Yeah, if you're going to call this x, then this one will go x minus 20, and this one will be 80 minus x, yeah. Because this one is gaining energy, and this one is losing energy, and they would be equal.
Feels like the last one we did yesterday.
That's because it is, because you probably have noticed the way maths and physics work is that I give you an example, then I give you questions. The questions are kind of like the examples, and then you can do them because you saw an example.
They are exactly the same numbers.
No, they're not. That's really 27, 20 something.
Yeah, 27 is so different from 20. Like, you can't believe how different it is. It's unbelievable. Like 7 units difference. Finish, Lee? Very good, very good. There you go. Correct. Well, I think it's correct. It's the same answer as Lee, so it's probably correct. What did you guess? Correct. So, do I even need to do the answer for this one? I'll write down the equation at least. Okay? So, this one is at x, and this one is at x, and this one is 0.05, and this one is 0.1. So, how much energy does this one gain? M. What's the C for alcohol, please? 2300. X minus 20. And that should equal 0.1, 4181, 18 minus x. What type of equation is this? Linear. So, what I'll do is I'll just have the program solve it. 0.05 times 2300 times x minus 20 equals 0.1 times 4181 times 80 minus x. Solve expression 67.06 is what a lot of people got. Very good. Okay, let's look at the next part. D. We're on D now, isn't it? Yeah. The whiskey-coffee mixture is now added to hot water. The hot water is mixed in now. What is the final temperature of this mixture? So what you just have, you now mix it with the hot water you have. What is the final temperature?
52.9.
I need to calculate it. No. It can't be. It can't be. It has to be between 67 and 100. Okay, try.
But what's the specific capacity of whiskey coffee mixture?
But you know what it is for whiskey, and you know what it is for coffee.
Do you add one?
No.
Yes.
No. Do what you did last time. Let me ask you this. Did you need to know the specific heat capacity of a whiskey coffee mixture here? No. No. You just needed to know what the whiskey was and what the coffee was. Yeah. So you can just do the same logic. You don't need to know what the mixture is. You just need to know what the whiskey is and the coffee is.
That's the M.
But you know what the M for whiskey is and what the M for coffee is. It hasn't changed.
But just add one hot one for each.
Okay, I'll do D since you all look so... You think you got it?
Yeah.
Okay, go on. Why is it so confusing here? You look so confused. Lee, do you know what to do?
So I have three equations.
Very
So you have three equations, all equal to each other.
Not quite. Okay.
Oh.
Wait, you've just realised what to do?
I think so.
Lee? Okay, that should be enough time. Yusuf? Lee? Okay, shall we see what happens? Okay. You have whiskey, coffee, and you mix it with hot water. How much whiskey? 0.05. Both of these are at 67.1, right? And what's this at? This is at 100, and its mass is 0.3.
85.6.
Okay, we'll see. We mix these together, and we have this, and this. 0.05, 0.1, 0.3, and they're all at X. So, this one is losing, this one is, this one is gaining, this one is gaining, and this one here is losing. So these two should equal this. So, M, what's the C here for espresso? It's the same as water, isn't it?
Yeah,
4181. X minus 67.1 plus M. What's this? Is this water as well? Sorry? I forget. What's the 0.1?
2300.
Oh, that's not. Oh, it's the other way. This one is the. This is the alcohol, isn't it? 2300, and the other one is the water. And that should equal MC 100 minus X. Now this equation isn't as bad to solve as it looks, because what's in common here? The X minus 67.1. So if you wanted to, you could take it out. Lee, can you type this in? 0.05 times 2300 plus 0.1 times 4181, please. What did you get? 533.1 times X minus 67.1, and then type this number, multiply this number. 12543.3, 100 minus X. So then next we have to multiply 533.1 X minus something equals 125430 minus 1254.3 X, 35771.01. So finally you could rewrite that as X equals 125430 plus 35771.01 over 533.1, that's 0.01 there, plus 1254.3. Can you type that in as well, Yusuf? 90.2. Now, of course, I could have made a mistake there. Is that what you got?
I got something similar. I got 91.4.
Okay, well, let me just check by getting the program to solve it. What was the equation? There it is. 0.05 times 2300 times X minus 67.1 plus 0.1 times 4181 times X minus 67.1 equals 0.3 times 4181 times 100 minus X. Solve. Expression. My handwriting is terrible. I must have made some mistake with my numbers. Unless I typed something in wrong here.
You had a mistake, I think, over there.
Where?
1, 2, 5, 4. Oh,
No. Maybe you typed it in wrong on the calculator. No. Okay, there's some small mistake in there. I'm so sorry.
Sorry.
Yes. Should be. This is what you got for one, wasn't it?
No,
Oh.
I got 85.6.
Great. We have 4 different answers.
I do in different way.
Okay. What way did you do it?
Like, it's a mix of whiskey and coffee, right?
Yeah.
So, the mix of it is ambient by 1 time. And the
C?
The B is 2POO plus 1 for 1 mid 1.
No, I added them.
Remember?
So I added them and I got. Never mind.
Brown bag. Yeah. Thank you. This is a bag. It is brown. One was a hard one. Now on to the next part. And then we still have to do that bullet question. Now the reason I'm spending so much time on this question is because students really screw this one up in the exam. It's almost quite rare for a student to get a question like what you just did right. In fact, you can see that I got it wrong. I screwed up one of the numbers somewhere. So it's a bit tricky.
Will they give us the specific table of this?
Oh yeah, they will, yeah. Okay, next one, E. The Irish coffee is placed on a window of the kitchen, which is 100 metres above the ground. The Irish coffee is knocked out the window. How much hotter will it be when it hits the ground? Know what to do? Oh, good, you have an answer. No. I think you misunderstand the question. How much hotter? The temperature. Believable. But just like Fawang's answer, doesn't make it right.
actually used prompt thinking in this one.
Oh, that's dangerous. Okay, let's have a look.
Wait.
Okay.
Can you ever add up their specific heat capacity?
Unlikely.
This one can't be done in any other way other than that. It's not possible.
Are you sure?
Positive.
It has to do with some other formula that has gravity.
Yes, you need
Yeah,
that.
other than that, that's the easy part.
Oh yeah. So here's the coffee. What temperature is it at? 60 or 81.7 is what we said, wasn't it? And here is, we'll say 0.05, 0.1 and 0.3. What were you saying about? Okay, we'll see, alright? Kilograms. Okay, so this one falls, and what happens is the potential energy up here is 0 down here. Where does this potential energy go? Kinetic, but then it hits the ground and it stops. Then it turns into heat. So the potential becomes kinetic and the kinetic becomes heat. So the potential becomes heat.
But it's not only heat. It's not only heat.
Just consider it.
Come on, life is hard enough, Yahya. We're just looking at heat. Although it'll be other things too. So this temperature, we call it X. And we know that X will be bigger than this. Yeah? So these all gain. So M, this is the alcohol, isn't it?
Yeah.
Which is 2300. X minus 81.7 plus 0.1. This is like water, isn't it? 4181. And both of them, right? So 0.3 4181 X minus 81.7. Now, because these two are the same, you can add them together. So this one just becomes yeah, why don't I simplify it a bit first? 0.05 times 2300. So that's 115 X minus 81.7 plus 1672.4 X minus 81.7. So that is 1787.4 X minus 81.7, and that equals mgh. What is the total m? 0.45 times 9.81 times 100. And somebody was saying something was impossible.
It's a close answer. What was the temperature at the beginning?
81.7.
So 0.2 is the change in temperature?
Yeah, it's not being heated up with.
Yeah, it's so 1 second. What did I say the temperature at the beginning was?
Yeah.
81.7, huh? Yeah, it's only like a quarter of a degree.
I got 2.1.
Yeah. It's
Just
good.
I get something close.
It is the right scale. I like this question. Okay. What?
You calculate only this one.
But I add these two together to make this. This one plus this one make this one. Because these are the same. Yeah?
We have 3.
Yeah, we had 3, but I put these two together.
Why not the first one?
Oh yeah, I could have put all 3 of them together in one go. I just, I was doing it bit by bit. So first I added these two, and then I added this one on. But you're right, I could have put all 3 of them together at the same time. I could have, yeah. Okay, continue. So, I think one final part. I hope you can all get this one by now. You've seen a couple of examples. So, it's rather cold. The temperature of the ground is 1 Celsius. The coffee will give heat energy to the ground. Why?
Nose.
Yeah, what rule is this?
Third. It's either the second or the third.
Second.
Yeah.
So, how much energy will the coffee give to the ground, the Irish coffee?
What's the temperature of the ground?
1.
What's the temperature of coffee?
You just worked it out previously. 82.
Is that after the strike of the ground? Yeah.
Yeah, because usually when coffee strikes the ground, that's when it pours out and cools down.
And that temperature was 82.
It was 82.
We don't know the thermal heat capacity of the ground.
No. You don't need to know it. Because I'm not asking for what the temperature of the ground is. I don't care. You just care to know how much energy was given away by the drink. You don't care what the resultant temperature increase of the ground is. Anyway, the mass of the ground is huge, so the temperature change won't be noticed.
Should they put coffee with whiskey?
Yes, we do.
It's normal.
It's nice.
But alcohol is
Yeah. And cream.
yeah. Only whiskey is
Go down to Leonard's Corner and ask them for an Irish coffee.
Is it hot or cold?
It's hot. Well, it's half hot and half cold. Because the cream on the top is cold and the coffee underneath hot. It's, of course, not halal. The only way it will be less halal is if it came with a slice of bacon stuck inside of it. What other foods are forbidden?
The way you kill the animal.
Oh yeah, okay.
Even go back to eat.
The answer? Yeah. You think I made a mistake? I need to check something. Did we get an answer for the last part? No! Oh guys, you're breaking my heart here. Lee? Okay, could be, yeah. Yeah, that's MGH is 441.45, I worked it out.
Where you get a 167.4.
That was the 0.1 plus the 0.3 times 4181. Because you can add those two together. Don't tell me I typed it in wrong.
And what about the 167?
That's the first of the three. I can't scroll up right now. It was the 0.05 times 2300. It was this one here.
No, that's 115. 178.74.
I added this and this. Believe me? Good. Right, last question now. What's the problem? I know, it's physics. Right, so the coffee spills out and starts to cool. How much energy is that? That's E delta theta, right? However, there are three things losing energy. First, the alcohol, 0.052300, and what is the energy loss, the change in temperature? 81. Plus,
82.
no, it's going from 82 to 1.
Oh, yeah.
Oh, the ground.
Yeah.
But still, that doesn't make sense to treat the entire coffee separately, depending on the ingredients it has.
What do you mean that doesn't make sense? I would say exactly the opposite. That makes perfect sense. Why does it make sense?
It's like you put three things together and you end up with a completely different thing, and you can go back to the three things you put.
I understand, but remember, there is no chemical reaction taking place. So although the coffee does mix with the water and the alcohol, and the mixture does have different properties and is not exactly the same thing as water, milk and alcohol or whatever separately. I know this. I know when you mix them together, it'll change. A little bit though. There's no chemical reaction taking place. It's not like you're mixing an acid and a base. So it's a pretty good approximation because there's no reactions taking place.
Why is it 4,300?
Sorry, I was distracted by Yusuf's remarks. 4181. I get what you're saying, because it's almost like you're treating the mixture as if they haven't mixed together.
Yeah.
But that is how we do these problems in physics, provided that no chemical reaction takes place or any other weird stuff like that.
Okay, and then after that.
That's it. Add these two together. That's the answer.
Really?
Yeah.
Yes, he added, and 81.
Yeah. What you get? Oh, and the 81. Thank you. Well, what you get?
1446661.
14466.
61.
Don't worry. It's just rounding, I'm sure. We'll just say it's roughly 145 kilojoules. Okay, how many people feel like they got the bullet question right last night? Good for you. Let's do it now. Okay, so what's the mass of the bullet?
It's 0.1.
And the temperature? We don't know. But you know the velocity is 100?
Yeah.
And this is lead. and it hits the wall. Yep. So what happens is this has kinetic energy and now there's no kinetic energy. Where did this kinetic energy go? Into heat. So you can say KE equals delta Q. So a half mv squared equals mc delta theta. So in fact, you didn't even need to know the m. And you get delta theta equals v squared over 2c, which is 100 squared over, and what's the capacity for lead?
129. 28.
Think about what you're saying. You're saying the bullet is nearly 40 degrees hotter when it hits the wall. So what temperature would the bullet be when you put it in the gun? It'd be room temperature, which is about 20. In Ireland it's about 20. When it hits the wall, what's its temperature now roughly? About 60. I think it's pretty amazing that it's gone from 20 to 60 just because it struck a wall.
Yeah.
Because of its speed only. And this has nothing to do with friction. Guys, this has nothing to do with friction. This answer would still be the same if you did this in a vacuum. Okay, it's not getting warm because of air friction. It's getting warm because it's stopping. So, even if this was in a vacuum, it'll still be 40 degrees warmer. The bullet, the gun would have to be outside the vacuum and would have to be fired into the vacuum because you would need air for the combustion.
So you can fire it again.
I think not, because of the gunpowder has to explode, which means you need a spark.
So you can explode in
No. It just means you need to make the spark a different way that doesn't require.
You can. For fire, we need fuel, oxygen, and heat. No oxygen.
Yeah, so you might have to.
Fire.
You might have to. I don't know.
You
Spread.
can't have a fire unless
You might have to have a modified gun that releases a burst of oxygen in the chamber before it fires. I don't know.
But then it won't get back.
It enters the vacuum. There are ways to make guns that don't use any gunpowder, that just use electricity, that fire a bullet. So you could still fire, but just not a regular gun. For those situations when you're in space in a vacuum and you need a gun.
You need to shoot someone.
Yeah.
It's really bad.
Alien 5 or something. Right, we got this one written down? Yep. Okay. So, we'll start the next physics lesson, but what I'll do is, I'm giving me a 5-minute break because I need to drink a coffee, okay? So I guess that means you get a 5-minute break too, but that's just an unfortunate byproduct. No, I wasn't doing it for you now.
Water.